Hello everybody, welcome back to the channel. This is Michael, KE4EST. And as you can see here, and as you've seen from the title, I have a PACO G30. This is a, as you can see here, RF signal generator and TV FM marker generator. It's been a while since I've had one of these. Looked inside one, but I remember these are pretty simple and should be a pretty easy restore. That is if somebody's not blowed something up inside or robbed some parts. So let's see. Can't see that on camera, but that's sticking out further than it should be, and it's kind of bent there. Let's see the knobs. Oh, that one's really stiff. Is it working? And this has got like this band. They use harmonics. This isn't really rich in harmonics. It's designed that way. So if you restore one of these, we'll look at it when I get restoration done. When you look at it on a scope, it ain't gonna be the prettiest sine wave you've ever seen either. But it was designed that way. You know, it's cheap, but you know, enough to get the job done, and rich in harmonics, so that we can go here and they'll go up to, what is it? I've got to pull a schematic up and everything. I've got one somewhere. I've got a whole folder on the computer with tons of these different things, radios and test equipment. 240 megahertz on the harmonics. But anyway, let's get this thing opened up here. See how bad it's going to be. It ain't too bad. It's got some scratches and scuffs, and somebody's rode on it there and something there. Most of this and some dirt. Most of that should clean up. Everything's here on the dial. Well, I was going to say it turns pretty good, but it probably can't hear that, but it's kind of scratching there a little bit. But it does it, yep, on the other end. So yeah, trying to look at it from the side here. This is a little bit warped. Let's see if I can straighten that out too. Everything's here, all the markings are here. It's yellowed over the years, but everything's there. Megacycles, E, F, G, G2, A, B, C. Everything's there. If there's somebody's broke off, to replace that. This here would be for the input or the output. If you want to go to external modulation up here, you can feed in a different signal. This one's probably, like I said, I have to look it up. Most like a lot of them, it's probably 400 hertz tone when you go to modulate RF. This will let you feed in a different, if you want 1000 hertz or 800 hertz or whatever. And then you can go to audio and it'll put the 400 hertz in here out on these jacks if you want to use that for something else. Of course, it's got one of these Amphenol connectors on it, and I've got, let's see, actually got one. It came with this one, and it looks like it's pretty old, but it's missing one of the alligator clips. This would have been made with 2 clips and one on the ground here. But if you've watched enough of my videos, you know what I'm going to do. I'm going to change this out to a BNC. If I want to use it, play around with it, I can stick in whatever. You know, I've got most everything I've got to BNC. So let's see here. Case ain't bad, too bad here. Alright, let's get these screws out. This is always the funnest part for me, or I don't know, funnest. Funnest, is that a word? This part here, even ever since I was a kid, taking something apart and see what's inside and see what makes it tick. And now being older, I know pretty much what's going to be in here, or what's supposed to be in here. But it's still exciting me to open it up and see, you know, if somebody else repaired this, if somebody else did a hack job on it, somebody's, who knows, you know, does it work? I've not, of course, not plugged it in. Being with this age, I don't want to, you know, I don't want to come apart easy, does it? Probably ain't been apart in a while. You don't want to take something and pry on it. If I can push from the back a little bit. Nope, that didn't work. Sometimes you can set them on their side and peck them a little bit. Listen, just don't want to come apart. There it goes. Alright. So, well, let me have it here. I don't want to mess that up. Set it down here. Get rid of that case. Okay, so we'll flip it around here now. And, yep, that's what it's supposed to look like. As you can see, there's not a whole lot to it. Use your band coils here. Starting with your, this of course will be your highest band. And that actually says it on them. See if I can zoom in there. See that right there? It says A. My pointer go. A, so somebody's actually marked this. Of course, a lot of these were kits. Okay, and that one's got a B on it. It's got a C. Oh, I gotta look now. D, E. Yep, F. They're all marked. And there's your. Whoa, let's not mess that. Get the light out of it there. Zoom back out here. There's the capacitor. It's going pretty smooth. Not binding. Almost sounds like it's binding there at the end, but that's on the front of it there. Okay, that's good. Okay. So, let's see what we got here. That resistor there. Allen Bradley. That's probably going to be okay there. That one's probably going to be okay. Is that some kind of a mold or not mold or something? Or yeah, that's supposed to be black. It's got surface dust on it, but not bad shape. And that, I don't remember what tube's in this thing. So let's see. Actually, so I guess this is the rectifier. Nope, that's not a rectifier. Let's try. That's 6C4. Okay. Yeah, go back in there for now. Alright, let's see what else we got here. They'll have to go. Them yellow ones. There. Pyramids. 0.02. That we know is going to be bad or going bad. Let's flip it around here. Let's see if we can look at the bottom without. I need to find something to set this on. Well, let's see. Let me look. Okay. I can do it like that and I ain't gonna hurt anything, but let's bring it. Let me move the camera. Okay. So, we got the capacitor here. That'll probably be okay. This tube here got shielding around it. That, yeah. That's probably part of the oscillator and all that. Yeah, that'd have to be the oscillator there. The RF oscillator. So I guess the other, me just look. Yeah, that 6E4's got to be the audio oscillator. This has got to be set making your audio tone. This is for your RF here. Okay, and then let's see. So that capacitor's got to go. This will definitely have to go. That's one of them duals. 20 microfarad. So that'll go. This here will definitely have to go here. That's across the line right there. See that? That's one of them dual capacitors. Essentially there's two capacitors inside this one housing here, sharing the same common, one leg common, and the other one side of the capacitor here, one side of the capacitor 1, capacitor 2, and they're just tied. This is tied together inside. And I've actually seen these split apart, and you can see just two separate capacitors where this comes off. If you take this off, you can see it. But yeah, that'll have to go, because if this shorts out, we're gonna have a bad day. So replace that with the safety capacitors. And well, I got it holding at this angle here. Well, we'll get to this in a minute. That's a roundy, that's a roundy, that's a roundy. Almost looks like it ain't, but that is. That's very interesting. Got some precision resistors here and here, but you got 3 roundies right here. And on the other side, remember up here, that move the camera. These up here. Let me look at that closer. Yeah, that's Allen Bradley style. Very nice and sharp. You can just tell by looking at the end of it real good. So that's interesting. A mixed resistor. So I have to check these 3 out here. I'll check them all, but these here 3 will be suspect for sure. And this will probably be changed out anyway here, because we get to this selenium rectifier. If you've not seen these before, this is the first type of diodes they used. This is like you can replace this right here with a 1N4004, 4007, something like that. And, depending on what voltage rating you need. But the voltage drop across this is different than the voltage drop across modern silicon diodes. So this right here, if we just change it straight out, this voltage is going to go up. In some cases, that's no big a deal, it's not that, big thing. But in this case, I'll probably change it out, being that this is a piece of test equipment, and we want this to be as close to factory as they want it to be. Plus, this may have been, I don't know, I find the stuff and read on it, what they calibrate everything to, but it might have been 110 volts, 115 volts. When I plug it in here, it's going to be about 122, 123 volts, just the way it is nowadays. So we'll get this, make the voltage here closer to what it, well, let's see, maybe the other side, but make the voltage closer to what it says, on the schematic, and go from there. So yeah, that's going to have to go. And I've seen posts where people, I don't know, I guess people just hear other people say certain things, or they've got people they follow or trust or whatever, and they're like, oh, Joe said to keep these things. These other people don't know what they're talking about, and I don't know, kind of like flat earth theory or whatever. Just because a couple people on YouTube say flat, the earth's flat, don't mean it's flat. So just because a couple people says keep those, they're fine, then you shouldn't listen to them, because these things here is like a ticking time bomb, just like these old capacitors. Leave them in, and I've seen cases where somebody has actually said, reading some forums and stuff, where they'll say, well, I left mine in because so and so told me to leave it in, or I asked about it, and they said, oh, leave it, if it works, it's fine, it'll be fine. And I've seen 2 different people, maybe 3, but I know 2, that said, well, I did that, and one guy said it wasn't like an hour or 2 after he got it restored, whatever it was, and turned on full power without any current limiting, and he got the smoke and stunk the room up. Another guy said his, I think, was like a year later or something. He was using it, and he turned it on one day and smoke went everywhere, and it was this because these things are going to go. So don't listen to people if they tell you, oh, they're fine, if it's working now, just leave it, it'll be fine. Because I've seen people say, well, if they fail, they're going to fail by now. So if they ain't failed by now, then they'll be fine for another 100 years. But no, that's not true. And if you get down to the chemistry of it and the physics of it, or really the chemical level and how these things work and stuff, it's just just like these oak capacitors. Seen the same thing with those. I'll just reform them and go with it, they'll be fine. And I've seen people do it with test equipment with these. Okay, and here's the thing, people will do it with guitar amplifiers and audio amplifiers because they like that old tube sound. Or really, it's not the tubes, it's these capacitors, because they overdrive the tube. And they like that sound because they start turning into a resistor and start leaking, and so, hey, they like that sound. This ain't a guitar amplifier. This ain't something I'm going to be, listening to music on or, want that sound, This is a piece of test equipment. You want to be as accurate as you can be. You want it to be reliable. You don't want to plug it up to test something. You're working on something and smoke goes everywhere, and you got to stop and work on this before you can finish something else. And I know a lot of guys, it'd be nice to have all this fancy test equipment that costs thousands of dollars, but if you can get you one of these cheap and restore it, it'll work for most things, if you're just restoring OEM radios or a couple of little small simple things to your ham radio, your amateur radio setup, you want to check something with the RF signal generator, this will be just fine. If you're not doing it for a living, doing it every day, you don't have to have the high dollar stuff. But you don't want to plug it in, turn it on one day, and smoke comes out, and then when you're trying to do something, that's aggravating. Especially when it's something well, somebody told me to change it, and then somebody else told me not to change it. So I went with the best thing to do is just change it. Like these resistors will probably have to be changed. Just the way it is. These roundies, they bad to go out of value. So over the years. The other Allen Bradley style, they usually hold their value, so we'll see how that goes when we measure them. But anyway, let me show it to you here. So let me go through and start restoring it, changing out these capacitors and all that. When I have that done, I'll clean it up some. I'll come back and we'll start going through it and see what it does. Alright everybody, I'm back, and you can see I went through and cleaned this up and got everything changed out, and we'll go through it here and show you what I've done. Start off with, I was looking, I'll find it just in a minute, lay the schematic somewhere. Well, I thought I was all ready, but alright, so what I've done is cleaned the knobs up. I have changed out this here with the B and C connector. I took all this off, took the disc off, took this off and cleaned it best I could with, a good mild detergent. And my finger and a soft rag and just, went over it both sides and cleaned off all the years of dust and smoke and whatever's on it. And still got a yellow tinge to it. So that's best it's going to be, because I don't want to go through and, get really some kind of harsh chemical in there and start taking this lettering off here. Bring you in a little bit more there so you can see everything's pretty nice on here. Everything's still there. I don't know how good you can see, but all the way down it's got all the red lettering there. So I've done that, put it all back together and cleaned everything up. So it's still got its scratches and marks, and part of it being its age, and this one's something that's kind of hard to go through, and you're never hard to match this paint up, so you think, well, I'll just respray it, but then I have to try to put all this back on, on all this lettering and everything, so we'll just leave that alone. And I'll turn it around here. So I went through and checked out through everything. These resistors, this resistor here was fine. Let's see. Yeah, I thought there was another one there. It's kind of hard to see now. There's another resistor. It tested out fine. And here, this capacitor here, changed it out to a new one. The bulb in here tests out fine. Let's not do that, it'll get too dark. There we go. That there checks out just fine. Cleaned all this up best I could. Now you can see, maybe you can see that, where at some point someone has, you know, with your hands being greasy, you know, or whatever. Now your hands will get that grease, especially if you're sweaty. You get a grease, you know, that just the moisture on your hands, you know, it's got the oils in it. And they've touched it like this here with their thumb, maybe messing around when they built it, put together as a kit, or went and changed something or checked something or whatever. And they've been doing this here with their thumb, you know, moving it around, and then they're like, okay, and then slap the case back on it. And I don't know if you can see it in the camera, but you can make out the prints, you know, somebody's print there. A little bit over here too, there's a big one. That's definitely looks like a thumb right there. So I went through and cleaned it as much as I could, but I didn't want to, you know, start taking off this coating here. So probably find somebody if the fingerprints are in the system and see who it was. But anyway, let's see. I'll flip it over here carefully. And yeah, I can do that. Let me adjust the camera. Whoop. About like that. Let me adjust this camera angle. This capacitor got changed out, of course. These checked out good. These resistors here checked out good. And of course they're precision resistors, so, you know, but sometimes I found them, you know, not good, you know. Older precision resistors, way they're made. I've been made a little bit better back then, but still not as good as they can be made nowadays, so sometimes they're off. These capacitors here, of course, got changed out, the filter capacitors. And these two here was this here. This one tests out okay, but if it was to fail, it's just a regular capacitor. I want safety capacitors in there since they're across the line. So did that. And then I came in here, checked these roundies, and yeah, I was right. There's every one off. Now one of them, I forget which one it was. I think it's the one hiding here. There's one hiding here. Up in here you can see. I think that was the one it was. It was pretty close, but I just went ahead and changed it out. Changed out that one. And this one here was a 2200 ohm. I went with a 3300 ohm and a little bit bigger resistor because you can see I got rid of that selenium rectifier. Changed it out with a, let's see, that's a 1N4007. It could have been lower than that. In this case, you know, the voltage ain't real high. I could have got, you know, went lower one, lower value, but I got plenty of these 1N4007, so that's what I put in there. Added terminal tie strip here, and I just left the screw that was in there because it's a real tall screw, tall screw to go through this, you know, that. So I just left that in there. I could cut it off, but it's not hurting anything, so I just left it, you know, what was in there. And I'll go over that in a minute, but when I measured this here, after, you know, changed out the diode, the voltage is going to come up because the voltage drop across a modern diode is, you know, a lot different than the voltage drop across the selenium rectifier. And I've got to find that schematic wherever I laid it. Let's see what this is. Yeah, here it is. Look on the schematic here. And there's that selenium rectifier. It says 130 volts and 110 volts. This here was 130 something. Once I got these filter caps changed out, I unplugged it in one time and brought it up, checked it, and I was getting, I think 130. Or maybe it was 120 something. Yeah, I think it was. Should have wrote it down. It was one. Anyway, it was higher, and it might have been okay, but this being a piece of test equipment, I want, like I've said before, try to get as close as you can. Even though this was a cheap unit, this is not, the most accurate unit. Still want to try to get things, as best you can. So it's got 2200, so I thought, well, I'll go with the next one up. And I tried a 3300, and it's real close to 110 volts now. And I went with the 2 watt, since we're dropping a little more voltage, but not that big a deal. But still, I went a little bit more because it's going to get a little bit warmer. Probably been fine leaving it 1/2 watt, but I went ahead and went with 2 watt. So now, when I measured that, like I said, it was around 110, or closer to 110, because it's going to be a little bit different. Line voltage here runs about 122, 123 at my house here. So this here, you can read that without me zooming way in. It says line voltage maintained at 117 volts for all voltage measurements. So it's going to be a little different, but in this case, like I said, it's not going to be that big a deal, with voltage being a little bit higher. But I didn't want it that high, so I went with that to drop it down a little bit. So I haven't went through all that. Let me plug it in. Hear me back out. Let me get it hooked up here and get the frequency counter turned on and everything, and we'll have a look and see what it does and do some alignment on it. Okay, I think I've got it all hooked up over there. You can kind of see over here in the corner. Everything's on there. I'll move this light here in a minute. Make it a little different. Now let's turn it on. Tube's lighting up. And let me go ahead and move this light. You can see we got this light here coming on. And let's see, how do I want to put this light here? Move this a little bit. You can see we're starting to get some action over here on this oscilloscope. You can see that. Let me zoom in over there for a minute. Now, if you have one of these and you get it all restored up and you want to go through and line it up and you want to look at it on a oscilloscope, that's what you're expecting to see right there. These were, low cost kit units, and that's kind of what you're going to see. You're not going to see, if you're expecting a perfect nice sine wave, you're not going to see it on one of these units. It's going to be like that for a couple of reasons. One, it's the least amount of parts they can use to make it work. And number two, it's designed to be rich in harmonics for this band, this G and G2 band, or G1, G2, however you want to call it, band. So, don't freak out if you see that and go, oh no, something's wrong. Let's see, I'm on band B. Let's go to band A. And you can see it is, there's what you're going to see there. I know that's probably hard to see. Let me do this just for a minute anyway. So that's what you're going to see. So I don't know how close this thing is, but the dial here there's 300. That ain't bad. 309. Okay, let me turn the light back on. Bring it back over here. Alright. Now, when you're doing this, of course, remember it's plugged in and running. It's not super high voltage, but it's got some high voltage in there, so you don't want to get zapped. If you're not comfortable doing this, don't do this, or get somebody else to help you do it or whatever. But Ain't a whole lot to line in one of these, but there's a couple of things we can go over here. We have, and I will mention too, I cleaned all these contacts, cleaned these potentiometers, cleaned them really, really good, you know, with contact cleaner. Before somebody's wondering if I did that. Clean these, you can probably see they're a little shinier in here, and just run them back and forth, back and forth, back and forth, back and forth, sprayed some more, ran it back and forth, clean all them up in there. But anyway, if you look here, you can see this coil, like I mentioned before, has got more turns on it, less turns, and they keep getting smaller and smaller. That is, if you look at the one that's got the most turns, is always going to be your lowest frequency. So right now it's on band A. And if we go back to where you can see the frequency counter, I come here at the tuning tool on A, and I've got the front at 300 kilohertz, kilocycles. See if I move this, see how that's coming down. And we can put that pretty close to 3. I'm going to stop about right there because I know it's not going to be accurate across the band. For one way this thing was designed to. I'll show you something else, because now, I don't know if you can, I don't know if you can see that really good. Zoom in just a little bit more so you can still see the frequency counter. So, let's go to 500. Okay, to me that's 500. You can see over there, about 490, about 10 off. So I can come in here on that band again and try to bring it closer to 500. Which won't be much. The higher up you get, the more it's less you have to turn it. Just touching it. So that's close to 500. Let's go back to 300. See, we're at 306. We're better than 309. But let's go way down to the bottom. Say 160. 158. Pretty close. We can. What you kind of want to do is, so some tricks I was going to show you is kind of go back and forth. Get this. Say, get this closer to 160. We'll go maybe 158. We'll bring this back to 500. 501.3. So very carefully, yeah, if I can get back on that. Just turn just a little bit, not much, like maybe that. Okay, it's getting closer to 500. Let's go back at the other end. 160. So now it's about the same as it was, ain't it? Let's see. Let's go a little more. Okay, it's getting even closer to 160. Now bring this back. 500. So that's showing 503. Yeah, maybe I'm not quite. 502.7. So that's the thing you know got with one of these. You know, it's analog. It's not the most accurate instrument. If this is all you got, like I've said before, this is just fine to use to line radios and stuff, you know, basic things anyway. You wouldn't want to probably get into it, especially if you have no frequency counter to go by. You know, if you got a good frequency counter like this, if the dial's off here, it don't matter. Just grab this and pull it to its, you know, on 500 or whatever, get it real close to 500, and if you need 500 kilohertz. But you don't want to go taking something like this and trying to line, you know, on these modern day HF radios and all that, because what you're going to do is you're going to go through, you know, without a frequency counter or anything, get as close as you can, but it's going to drift off. And this, you know, this dial's an analog dial. This might be off a little bit, this be off a little bit. you know, and it's going to drift a little bit. And you go and line up the HF radio, and then you get on there, and you're on 40 meters, and you're on 7240. You got your dial reading 7.24.0000, all zeros it'll give you. And you got another guy you're talking to. He's going to sound off frequency to you. He's going to come back and say, man, you're off frequency a little bit. And you're like, man, I lined it up with my signal generator. So, you know, you're going to find that you're probably, you know, especially if you're messing with the oscillator in there, you're going to have it off a little bit. So you're going to sound a little tinny or a little bassy, sound a little funny, you know, especially, you know, on sideband. So you might get away with it on AM, but sideband. But another thing I'll mention too, you say you don't, you know, have a whole lot of money, you want to get this though to play with to line some old radios or whatever. If you've got any kind of modern AM radio, put it on 500, or, well, let's see, let's go a little more than that. Go up to the B band, you know, put it on, find, you know, a spot where you don't have a radio station. Tune your radio, say, to, if you can, to 1,000. And go to this and put this on 1,000. Make sure you go over here and turn this to turn the tone on. And then adjust it to you know, and get that tone in there. You use AM radio. If you have an HF radio, like the one you see behind here, use that. And that, you know, will go down low enough to tune all the bands on this. Except for, you know, those harmonic bands. You'll be able to use that to tune all of them, you know. But that's what you want to do anyway, getting back to it. You want to go back and forth and get that from, say, 500 on band A to 160. Back and forth, get that as close, you know, split that. It takes time. It takes a lot of time, you know. The more time, you know, I have to do on this video. Make sure it's turned on, make sure it's warmed up for a while. And go back and forth, until you get as close as you can. And then what you can do is let's go back to A here. And let's put this on 300. And say you're messing with it and you're getting it close. Let me get this closer. Yeah, man, I'm really getting this close. So say you got 302. And you go to 500, it's 501 or something. And 160s, 59. Or, man, I'm getting really close here. You can, let me go back. Let me put it back on 300 where I can see it. You can come around here. You know, some, like if you're tuning a radio or some fancier signal generators or more expensive ones have adjustments on both ends. You know, you have a capacitor on one end to adjust and a coil on the other end to get that frequency more accurate on the dial. What you can do is come in and find something of all the stuff I got laying here. You definitely want something non-metallic and be very careful. I thought I held it. Well, I'm glad that wasn't a snake laying right there. Let's bring this light back here. Let me change the camera. You see these fans here on this tuning capacitor? And you see how these outer fans have little slots cut in them? The inside fans don't. Of course, you couldn't move those anyway, because you'd start, you know, having problems when you tuning it, you know, and it would get in here and bind up. But these outer fans, they are designed that way. It's not for heat dissipation or anything like that. They're designed to go in and adjust. And you can go in and do that. You can go into these and you can just start off with, you know, flexing things just a little bit. See what moves or what changes. And watch your frequency counter. And then you can go in with something, you know, very careful, a small pair of needle nose pliers that's insulated. If you have to take and wrap some black tape around the end of them or whatever. And some of these you can touch this and you're fine while it's hot, and some of them, it's hot, so you gotta be careful. So maybe it's, a good idea to do that. But now if you use something metallic with tape wrapped around, when you go in there, it's going to change it, and then you pull it out, it's going to change again, so it's going to make it a little more hard. But what you can do, if you go over here and look at this frequency counter again, I'm going to move. I'm not turning the dial. See how that's dropping in frequency and getting closer. I'm moving these fins, and they're mostly springing back, but what I done was, just pardon the camera movement here, this fin right here, I'm flexing it out like that, see, and you can bring it around and get, another one down here. I'll move it out if it gets better, and then bring it back to 300 or whatever frequency you're using, for your reference. And the different bands, as you get higher in bands, you can use this side, and then you get real high up in the bands, over here. But you can adjust those out to try to make that dial track on the front a little bit better. So that's a lot of thing. Something I've noticed that a lot of guys miss or didn't know. Just wasn't taught that, especially if you're trying to learn this stuff now. I'm sure it was taught that years and years ago, but now it's just everything's digital, right, and synthesized and all that. But anyway, that would be something to help you there if you want to try to get it close as you can. But just remember, if you're using one of these and that's all you've got, and you don't have the money to get something fancier, or you don't want to spend money on something fancier, you want to mess with a few AM radios, old, tube radios, and get them going or something or whatever, or a few little things in the ham shack. Something like this will be just fine. You're not a repair shop, you're not doing it for a living. And just remember one thing, if you come in and I'm trying to set this thing, if I go right past that 450, let me show you what they've, maybe you can see it. Bring it out here. If you look right here, use this pointer. Right there, maybe you can make that out. It says 456, which was a common, and there's a little mark before to be 455, which, common IF stage, right? Well, if you go here and you get this, you're going to do a lot of those, so you want to set and mess with it. Well, too bad, look at that. Pretty close enough, but watch it move a little bit there. Yeah, I blew on it and it changed a little bit, the fan. That fan I got running over here, but of course you want the case on it when you're using it. But remember, so you got this, you get it as best you can, but this drifts over time a little bit and it's off, and you got it right on. Well, that's 455. Well, when you get to if you had a frequency counter hooked up, it's 454. And you go through and line up an AM radio. It's not going to hurt the sensitivity. Your radio's still going to work. The main thing you're going to see is, if your dial's moving. Let me back this out a little bit. I'm just going to use this. Say this is your dial here, and there's your pointer, and this 30 here is 1000 AM or something. So you move your dial back and forth. If you get it anywhere close into here, the tune to your favorite radio station, you're still going to find it, right? And it's not going to, the 455 being off, you set it to 454 is not going to affect your sensitivity. So it's still going to sound good. I'm not advocating that and saying, oh, don't worry about it, it'll be good enough. But, always make things as best you can be. But if you can't, this is what you got, it'll be just fine. Don't worry about it. If you get into more detailed stuff and want to, get better, you definitely want to get a frequency counter, and probably a more modern one of these too. So I hope this has helped somebody out. If they've got one of these, want to restore it, go through it. Don't forget, if you want to, leave some comments down below or questions. I'll be glad to answer them when I can. If you like to hit the like button, subscribe, all that stuff. And until the next video, this is Michael, KE4EST 73.